All right, next example. We are still factorizing monic quadratic trinomials, and now we're looking for two numbers whose product is -10 and whose sum is +3. Okay, I just want to point out here that it's not always possible to factorize monic quadratic trinomials using this technique. As we'll see in upcoming examples, sometimes we need to consider other techniques. So of course here I happen to have presented trinomials that can be factorized this way, but let's bear that in mind. So pairs of factors of -10, we have -5 and 2, but the sum of those two numbers is -3, not +3. So let's choose +5 and -2. Okay, -10 is equal to 5 times -2, and 3 is equal to 5 plus, -2. Right, this allows us to factorize the left-hand side like this. So we have +5, -2, okay? Using the null factor theorem, we can conclude that x is equal to -5 and x is equal to 2 are both solutions to this equation. Quick verification of our solutions. So plugging in x is equal to -5, we get -5 squared is 25. Okay, plus 3 times -5 is -15. -10. Okay, this is equal to -10, sorry, +10, -10, and that's equal to 0. So -5 is correct. Now let's check x is equal to 2. 2 squared is 4. 4 plus 3 times 2 is 6, -10. Okay, this gives us 10 minus 10, and that's equal to 0. Okay. Using CAS, menu, algebra solve, equation, x squared plus 3 times x minus 10, comma, x. And notice here, we have an error because I did not input an equation, right? Solve must have an equation, equals 0. Now we have our solution. Okay, -5 and 2. Next example. We are looking for two numbers whose product is +10 and whose sum is -11. Okay, so we notice that we must have two negative numbers because the product is positive, but the sum is negative. The only way for that to be true is if both of our numbers are negative. Okay, and -10 and -1 satisfy these criteria because 10 is equal to -10 times -1, and then we add these two numbers. So -10 plus -1, that's -11. So we're able to factorize as follows. It's 10 minus 1. Right, giving us two solutions. X is 10 and x is 1. Okay, quick check in our heads. 10 squared is 100. Minus 11 times 10 is 110. Plus 10. This gives us -10 plus 10 as 0. So our first solution is correct. Right, check. We can do this in our heads, hopefully. Okay, 1 squared is 1. 1 minus 11 times 1, so 1 minus 11 is minus 10. Minus 10 plus 10, 0. Okay, if we had access to a calculator, we would have saved time by solving the equation x squared minus 11x plus 10 is equal to 0, comma, x. And there we go. All right, last example. There are actually two ways to approach this equation. The first method would be recognizing that this is a perfect square, namely x plus 3 all squared. Okay, the reason I say that is because recall this result, that the square of a plus b is a squared plus 2ab plus b squared. Okay, and I'm going to write that 6 is equal to 2 times 3 and 9 is equal to 3 squared. Right, so notice that x here plays the role of a, and 3 here plays the role of b. Okay, now this tells us that we actually only have one solution, so x is equal to minus 3. Remember that we can check how many solutions we expect a quadratic equation to have by computing something known as the discriminant, which is equal to b squared minus 4ac, where b is the coefficient of x, a is the coefficient of a, which is always 1 in monic quadratic trinomials, and c, which is the constant term. So in this case, the discriminant is equal to b squared, so 6 squared, minus 4 times, well, a is 1, and c is 9. Right, this is equal to 36 minus 36 is equal to 0. Remember, discriminant equals to 0 told us that there was one solution to the equation y is equal to 0, where y is a quadratic equation. So x is equal to minus 3 is our solution. Now, let's say we were not able to recognize that x squared plus 6x plus 9 was a perfect square, right? That's not a problem. We could have still employed the same technique that we've been using, looked for two numbers whose product is 9 and whose sum is 6, right? And we conclude that those two numbers are 3 and 3, because 9 is equal to 3 times 3 and 6 is equal to 3 plus 3, right? So this would have told us that we could rewrite our equation as x plus 3 times x plus 3, which is equal to 0. Or equivalently, x plus 3 squared is equal to 0, right? But recognizing the perfect square did save us some time. Right, let's double check how we would have obtained this result using CAS. We did not want to spend the time factorizing. X squared plus 6x plus 9 is equal to 0. X is equal to minus 3.